Hello everyone. Today we will solve an equilibrium problem. Here the problem states a 500-pound cylinder A rests on a smooth inclined plane. Figure 41, which is this one. For a tension in the rope of 250 pound, find the inclination of the plane and the plane reaction. Solve algebraically and graphically. So here we will have to find two things. First is the inclination of the plane or the angle of theta. And then the reaction of the plane or the inclined plane. We will have to find the reaction of it. So let's start by drawing the free body diagram. First, let's draw the horizontal axis and then a vertical axis. For the cylinder, the weight will pull it downward. So let's indicate it and write the value of it. Here, the rope is parallel to the inclined surface. So it will also have a theta angle with the horizontal axis. So let's indicate it here. This angle is theta and the value of the tension in the rope is 250 pound and the reaction of the surface will be perpendicular to the surface. So it will be 90 degree with the surface and we can replace it here with the tension in the rope. So it will be 90 degree from the rope. And let's call the reaction R. Here this is the 90 degree angle. So it will be, here we can see that the whole horizontal area is 180 degree. So if we remove the 90 degree, which we know, we will have 90 degree. So this portion and this portion equals to 90 degree. So if we remove the theta, then we will get 90 minus theta. This is the angle. Here we can see that this whole thing has three-word directional forces. So we can apply Lami's theorem here. So let's indicate the alpha, beta and gamma angle. For that, let's say this is alpha angle and this is beta, and then we can say this one is gamma. So let's write it down. By applying Lami's theorem, (500) divided by sine alpha equals R divided sine beta equals 250 divided sine gamma. Here alpha equals 90 degree. For beta, we can see that this is a 90 degree angle. So we can write 90 plus theta degree. And for the gamma, we can write, here we have 90 degree and this is 90 minus theta. So if we write it like this, 90 plus 90 minus theta, so we can write 180 minus theta degree. So let's apply the values here. 500 sine 90 equals R divided by sine 90 plus theta equals 250 sine 180 minus theta. We know that sine 90 equals 1, so we can write 500 equals sine 90 plus theta. If we simplify it, we get cos theta. So we will write that. And then if we equals 250, and if we simplify sine 180 minus theta, we will get sine theta. Let's use this portion and find out the value of theta. So we can write 500 equals 250 by sine theta. Then we can write sine theta equals 250 by 500. Or we can write theta equals sine inverse half. So the theta will be sine inverse 0.5. We get theta equals 30 degree. So the inclination of the plane is 30 degree. So now let's find the reaction of the surface. For that, we can do it here. If we write r cos theta equals 500, we are using this portion, and if we write r equals 500 into cos theta, and let's apply the value of theta, then we get 500 cos 30. So the value of r will be 500 cos 30. It would be 4033.01 pound. So these two are our answers for this problem. Thanks for watching.